Hey everybody, Mr. Kowalczyk here. Today we're going to talk about Unit 5, quadrilaterals, and today we're going to be doing Lesson 2. In this lesson, we're going to be talking about Standard 9.2. I can use the properties of rhombi, rectangles, and squares to identify and solve related problems. Now, yesterday we did parallelograms. Today we're going to be doing rhombi, which is the plural of rhombus, rectangles, and squares, and we'll talk about related problems. Now for the opener, please go ahead and solve for the area and perimeter of this rectangle. Go ahead and pause the video and solve those, please. All right, so hopefully you paused and had a go at it. If you've forgotten, the area of a rectangle is equal to the length times the width, and it's measured in units squared. And that's the space that the inside of the shape covers, or the amount of paint that would be needed to cover the inside of a shape. And we measure that in square units. And then the perimeter, well, let's go ahead and solve for the area first. The area is equal to length times width. So in this case, it's just equal to 11 inches times 7 inches, 11 inches times 7 inches, which equals 77 inches squared. And then the perimeter is equal to the distance all the way around the shape. So that's going to be the length plus the length plus the width plus the width, because in a rectangle, we know that opposite sides are equal to each other. So here we have 11 inches and here we have 7 inches. So that distance all the way around is going to be our perimeter. So here we have 11 plus 11 plus 7 plus 7. That's going to be 22 plus 14, which is going to give me 4 plus 2 is 6, 1 plus 2 is 3, 36 inches. And we just measure that in inches because it's a length. We don't measure it in square inches like we did with the area. All right, cool. So next, we're going to move on to the notes. So check this out. For today's notes, so yesterday we worked on the properties of parallelograms. For today's notes, we're going to begin filling out what we have as called our quadrilateral family tree, which is at the end of lesson 2. So this is going to help us with all forms of quadrilaterals. And today we're going to fill in both the parallelogram section as well as the rhombi, rectangles, and squares for this lesson here. So let's go ahead and turn a few pages to get to that quadrilateral family tree. Looks like this, okay? And we're going to fill in the parallelograms as well as the rhombi, rectangle, and square, okay? So now the first side, there are two sides to this, as you might see. There's the back side, and they're both blank. So here on this side, what I want you to do is just go ahead and write in the definitions. So this one side is going to be the definitions of all of these particular shapes. We're not going to fill them all in today, but we're going to fill in most of them on this side of the sheet, okay? We'll worry about the other side in just a minute. So the first shape that we have here is a quadrilateral. That's the most general that starts up here. And the definition of a quadrilateral is a 4-sided polygon. That's all we need to have a quadrilateral, okay? We just need a 4-sided polygon. Now, for a parallelogram, the definition of a parallelogram, you might remember from yesterday, is 2 sets of opposite and parallel sides. So this looks like we mark it up with our arrows. We have 1 set of arrows here, and then we have 2 sets of arrows here that indicate that we have a parallelogram. Okay, so that's all we need in order to have a parallelogram. Now, for today, what we're moving on to is a rhombus, rectangle, and square. So we have these 3 shapes. Now, you'll notice in the parallelogram family tree that as this branch comes down, we're now in the parallelogram branch. So everything that's underneath this is also going to be a parallelogram. So in this case, both the rhombus and the rectangle are parallelograms as well as the square. So rhombus, rectangle, and square also have two sets of opposite and parallel sides. Now a rhombus, the way that we know that we have a rhombus is by having four congruent sides, which means all four sides are exactly the same length. Now the difference between a rhombus and a square, because a square also has four congruent sides, is that a square has four 90-degree angles. So we'll get down to that in just a second, but I wanted to mention that because you might be thinking, well, how is a rhombus different than a square? So a rectangle has four congruent 90-degree angles. So that's what we need to have a rectangle. Now, how do we get to a square? Well, for a square, we take both of these definitions and they have to be in here in this one quadrilateral to have a square. So a square has to have both four congruent sides as well as four congruent right angles. So four congruent sides and four congruent right angles. This symbol right here means angles, okay? All right, so those are our definitions. That's it, we're done with this side. Now let's flip over to the back side. And this one's going to get a little bit more specific. So on this back side, what I'm going to do is I'm going to call this how to prove that we have a ... So what I mean by that is, how do we prove that we have a quadrilateral? How do we prove that we have a parallelogram, a rhombus, a rectangle, a square, and so on, okay? Again, today, all we're going to do is we're going to be filling out this side of the form. If you do have a couple different colors, this might be great, highlighters or pencils or whatever, you'll see that I'm going to use a couple different colors, especially when we get to the parallelogram, okay? Now, quadrilateral, that one's pretty straightforward. We have four-sided polygon. Now, that's of course the same as the definition. That's the only way that we can prove that we have a quadrilateral. So there's only one reason there. But for the parallelogram, there are actually 5 different ways that we can prove a parallelogram based on the 5 different rules that we talked about yesterday. So let's jot those down. The first one is that we have 2 sets of opposite parallel sides, like we just talked about. Okay, so I'm going to put a bullet here. 2 opposite parallel pairs. Okay. Now I'm going to use a different color for the next one. In the parallelogram, we also said that we can have opposite sides that are congruent. So congruent opposite sides. All right, so that's our second way that we can prove we have a parallelogram. Our third way that we can prove we have a parallelogram is opposite congruent angles. Okay. And then our fourth way that we can prove we have a parallelogram is that we have diagonals that bisect each other. Right, this is congruent to this is congruent to that. Okay. Diagonals bisecting each other. And the fifth and final way that we can prove we have a parallelogram. Let's see, I'm running out of colors here. Oh, I have blue. We have congruent and parallel opposite pair. So what that means, right, is that we have a congruent and parallel. So I'm making this in blue, so it's parallel and congruent. So if one pair of sides is both parallel and congruent, then we know we have a parallelogram. So lots of different ways for the parallelogram. I know this is pretty cluttered. The other ways that we're going to use here for the rhombus, rectangle, and square are not going to be as cluttered. All right, rhombus. if we have a rhombus? Well, we had already said that we have 4 congruent sides. So that's going to be one of our ways that we have a rhombus. The second way that we can prove that we have a rhombus is the diagonals. Now in a rhombus, the diagonals are special because this cool thing happens where the diagonals form 90-degree angles with each other. So the 90-degree angles at diagonal intersection. You could also say that the diagonals form right angles, or perpendicular diagonals would probably be a much more succinct way than writing that. So you could also say perpendicular diagonals, I guess. All right, now the last way that we can prove that we have a diagonal, a rhombus, is with these angles here. And what happens in a rhombus is that these angles get bisected or split in half by this diagonals. So each of these are going to be exactly the same. And then each of these here are going to be exactly the same also. So the diagonals are going to bisect or split in half this whole angle here and this whole angle here as well. Okay. So let's put that down here as neatly as we can. Diagonals bisect opposite angles in blue. Okay. All right, now let's move on to a rectangle. For a rectangle, we said earlier, we need 4 right angles. So if we have a quadrilateral with 4 right angles, then we know we have a rectangle. Now there's another unique way where we can prove this, and that's, and I'm going to do this in Sharpie because I want it to stand out. If we have 1 right angle in a parallelogram. So a parallelogram, that's our symbol for parallelogram, with 1 right angle. Then if it's a parallelogram and it has 1 right angle, then we know that all of the others have to be right angles. And here's why. Because opposite angles are congruent, so that makes this a right angle. And we know that in a parallelogram, same side interior angles are supplementary. So 90 plus what has to be 180? Well, this has got to be 90 also. Same thing over here. So if we have 4 right angles in a quadrilateral, or we have a parallelogram with 1 right angle, that tells us that we have a rectangle. Now, the other way that we know that we have a rectangle is if the diagonals are congruent to each other, meaning they're the same exact length. That's not true for a rhombus or a parallelogram or a quadrilateral, but in a rectangle, the diagonals are exactly the same length. So I'm going to mark this up with brackets, which means the whole length of the diagonal is congruent to the whole length of this diagonal. It's a little bit awkward and clunky, but if I were to mark just this part over here, then it could seem like half of the diagonal, sorry, was congruent to something else. So I want to be clear about that, but it's the whole length of the diagonal being congruent. All right, now finally we're down to a square. Oh wait, we have congruent diagonals. Now with a square, what we said earlier still holds true. If we have 4 right angles and 4 congruent sides, okay, that's going to make a square. 4 right angles and 4 congruent sides. And finally, for a square, we have this special rule where if we have a rhombus with 2 consecutive sides or adjacent sides that are next to each other that are congruent, then that makes a square. It's a rhombus. We know that if both of these sides are congruent, or if both of these sides are congruent, then the opposite sides also have to be congruent, making all 4 sides exactly the same. So our second and final way to prove a square is a rhombus with two adjacent congruent sides. All right, so that is the notes for today. What I'm going to have you do now is go back, so turn back to where you were with lesson 2. Let me turn back my pages here. And what I'd like you to do, I'd like you to start with question number 1 and use the properties, the definitions, and the ways to prove that we just talked about in order to answer all of these questions. If you want to wait till tomorrow in class, you can do that as well. So which is not a property of a rectangle? For example, let's just do number 1 together. Diagonals are congruent, diagonals are perpendicular, diagonals bisect each other, all 4 corner angles are congruent. Well, we know that in a rectangle, all 4 angles have to be a right angle. So that's true. Diagonals bisect each other? Well, yeah, that's true because a rectangle is a parallelogram. Diagonals are perpendicular. Well, that happens in a rhombus, but not in a rectangle. And let's just double check here. Diagonals are congruent. Yep, that's one of the properties of a rectangle also. So therefore, B, diagonals are perpendicular, is our correct answer because that's the only one that's not true. All right, let's stop there for now. And the rest of these 2 and on through the rest of the practice problems, y'all can have a go at tomorrow in class. All right, we'll see you then. Have a good day.